This is 4.1, the problems from some other book that I have, that I like. This is the assignment we're calling assignment number 2. And we're doing, let's see, we're starting at 27 and doing 27 to 31. And that's all of those. Just in case you only did the odds, you better pause this video. Go back and do those evens too. Not for any other reason than there's just not that many of them. And I think this is an important kind of problem. Can you tell that that's a 27? It's tough. So in 27 and 28, we're given one of these equations in x and y, and we're supposed to find dy dx at a given point. So there's nothing different here from what we need to do here compared to what we need to do, or what we were doing in assignment number 1, except that at the end we're going to go ahead and find the derivative at a particular point. Right? Well, that's an x value and that's a y value, so we'll just plug those in. All right. Now, let's see. Can you distribute this 6 here? Oh, that'd make it easier. No, no. Oh, no, you can't do that because that's bad algebra, because this exponents are higher up in the order of operations, so you cannot multiply before you do that. You could FOIL this out and then distribute the 6 if you wanted to. I don't think that's going to make it any easier. All right, so let's get into the calculus here. What's the derivative of something to the second power? 2 times the something to the first power times the derivative of what's inside, but the derivative of what's inside, this is just 1, right? Derivative of x is 1, derivative of 2 is 0. Okay? Minus 6, and then I got to square it here, so when I take the derivative of that using the power rule, that's going to slam down into that 6, make it a 12, times this to the first power times the derivative of what's inside. The derivative of 2y is 2 dy dx, and the derivative of the 3 is 0, so plus 0. Okay? Derivative of this 3 is also 0. Now you got a choice. We're here in, if we were doing this problem like what we did in assignment number 1, we would solve for dy dx, do some algebra and move stuff around. And you could totally do that, but here we actually just want to find dy dx at this particular point. So you can either solve for dy dx and then plug in this for x and this for y, or you can plug in this for x and this for y right now after the calculus. You can't do it first. You have to do the calculus first that we just did. But I could plug these in now. So just to give you a different take on this, I'm going to do it that way. So again, your other option would be to do what we did in assignment number 1 and then plug these in. I'm going to plug these in now. So 2 times 1 plus 3, or 1 plus 2, sorry, getting ahead of myself, minus 12, and then 2 times y is negative 1, so 2 times negative 1 is negative 2, plus 3, times 2, dy dx equals 0. And now I just have numbers to deal with. I don't have to do as much algebra doing it this way. It's an option. So 2 times 3 is 6, minus 12 times, this is 1, times 2, dy dx equals 0. So that's 6 minus 24. You know what stinks? If you do all the calculus right and then you make like an arithmetic mistake or like order of operations, some kind of baby algebra thing. That's a bummer. So please be careful. So dy dx is 6 over 24, or 1/4. And that's at that point. All right, we just found the slope of this curve at this point. Cool. 28. Same thing, except this time I've got sine squared. I don't like that sine squared notation, so I'm going to rewrite that. That means this, right? Equals x plus y. And we're finding this at the point 2 minus pi over 4, comma, pi over 4. Let's see what we get. Derivative of something squared is 2 times that something to the first times the derivative of what's inside. The derivative of sine of whatever is cosine of whatever. And the derivative of what's inside that, because there's another layer. We knew this. It's like the Russian dolls, right? There's 1, 2 layers. So we knew that there was going to be the first thing, and then first Russian doll pops out, and then derivative of the what's inside of that, which is 3 dy dx. On this side, derivative of x is 1. Derivative of y is dy dx. So let's go ahead and try just plugging these things in and see what happens. So 2, in other words, do it like what I did here, times the sine of 3y, that's 3 pi over 4, times the cosine of 3y, times 3, times dy dx, that's the thing we're trying to find, is equal to 1 plus dy dx. Alright, so I guess I need to know what the sine and cosine of 3 pi over 4 is. Good thing I took pre-calculus. So the sine of 3 pi over 4, that's, if you're imagining, here's my center of my unit circle, that's here, 3 pi over 4. So the sine is the y-coordinate, that's the square root of 2 over 2. The cosine of 3 pi over 4, that's the x-coordinate, is negative square root of 2 over 2 times 3 times dy dx equal to 1 plus dy dx. Okay, so let's see. The square root of 2 over 2 times the square root of 2 over 2 is 2 over 4, or 1/2. That's a negative sign. That's a 2. So if you multiply 2 times negative 1/2, you get negative 1 times the 3. You can plot that out and do that math in a little bit more detail if that makes you happy. Alright, what do I do with this? Well, if I subtracted this over, here's negative 3 dy dx's, so if I subtract that over, that's minus 4 dy dx's equals 1, so it looks like dy dx is negative 1/4. That's how you do that. Alright. Number in 29 through, let's see, which ones are we doing? 29 through 31 and 33. We're finding a tangent line at the given point. So this is real similar. We're going to do exactly what we did here, but once we get to this point, we're going to use that slope in whatever point to write the tangent line. In point-slope form, so if you know point-slope form, like at that, there's nothing else to do except write down the answer at that point. At that point. Huh. That's funny. Alright, so let's try 29. X, Y, right off the bat, I'm thinking, okay, product rule, watch out. Equals 1, and we're going to do that at the point 3, 1. Okay, so derivative of x times y, derivative of the first times the second, plus the first times the derivative of the second, that's product rule applied to that, minus 2 dy dx equals 0. Same deal as before. You could solve for dy dx and then plug this in, or you could just plug it in now. It's up to you. I'm going to go ahead and plug in my x and y values. So it looks like I've got 3 dy dx's minus 2. That's just a dy dx. So 1 minus 1 plus dy dx equals 0, so dy dx is equal to negative 1 at this point. Okay, that's my slope. So the equation for this line in point slope form, y minus the y-coordinate equals the slope times x minus the x-coordinate. All right, number 30. X squared times y cubed plus 2y equals 3x at the point 2, 1. Product rule, derivative of the first times the second plus the first times the derivative of the second. Derivative of 2y is 2 dy dx. Derivative of 3x is 3. Same option. You can solve for dy dx if you want, or you can just plug these in right now, since we're only looking for the derivative at this point. Okay? Plugging in the 2 for the x. I got 2 times 2 times 1 cubed plus 2 squared is 3 times 1 squared. That's just 1. I don't know why I wrote that cubed there. It's just 1, right? You can write it or not. And 2 dy dx equals 3. Time to do math. 2 times 2 times 1 is 4. 4 times 3 times 1 is 12. Alright, I got 14 dy dx. If I subtract this over to the other side, 3 minus 4 is negative 1, and then I'm going to divide by that 14. So, that's my slope. So y minus 1 equals the slope times x minus 2. Next problem, it's getting a little crowded there, sorry, is this, and there's my point. So derivative of x to the 2/3 is 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 times dy dx. Every time you take something, the derivative of something with a y in it, that pops out, and the derivative of 2 is 0. This one's a lot easier if you just plug this in now, I think. Well, a lot. It's marginally easier because 1 to whatever power is just 1. So 2/3 times 1 to the negative 1/3, that's just 1. 1 to the negative 1/3 is just 1. dy dx equals 0. So a little bit of math, and so dy dx has to be negative 1. So y minus 1 is equal to negative 1 times x minus 1. And the last one, number 33. See if I can fit it in down here. X to the 1/2 plus y to the negative 1/2 is equal to 2xy. So product rule, alert. So here, derivative is 1/2 x to the negative 1/2. Oh, I forgot to write down the point where I'm doing it. This is also at 1, 1. And then that comes out to the front, so maybe I'll write that as a minus here. Minus 1/2 y to the negative 3/2. Just took the derivative of something with a y in it. Alright, on this side I'm going to consider 2x to be the first and y to be the second. So derivative of the first times the second plus the first times the derivative of the second. Alright, so I'm going to plug in the 1, 1 now. Let's see, the 1 to the any power is just 1, so this is 1/2 minus 1/2 dy dx is equal to 2 plus 2 dy dx. So let's see what we have here. If I add that to here, that's 2 is the same as 4/2. So that's like, if I add that over here, it's 2.5 or 5/2 dy dx. And then if I subtract this 2 over to here, 1/2 minus 2 is negative 3/2. So dy dx is equal to negative 3/2 over 5/2, which is negative 3/5. And now I'm ready to write my answer. Y minus 1 is equal to negative 3/5 times x minus 1. And that is it.